This is the WaVe Unmanned Water Vehicle for Engineering and Education project. The students involved are Larissa de Rosario, Jomar Ramírez, Ángel Ocasio, Kevin Ortiz, Joshua Cruz, Derek Laureno, Nunila Dávila, Ángel Justiniano, Luis Romero, Isamarie Vega, y Sofia Torres. Faculty Advisor, Eduardo Ortiz. Autonomous robots are intelligent machines capable of performing tasks in the world by themselves without explicit human control. Objective. This research project, conducted by the students of the University of Puerto Rico Mayagüez, consists of creating a prototype of an unmanned water vehicle with the purpose of fulfilling all ABET requirements and be able to pass along these learning techniques through outreach programs.
The first thing we needed to solve was making a low-cost, low-budget catamaran-style vehicle for the structure of the robot. That led us to the design process, that being making different iterations, comparing them for their pros and cons. We decided to go on the final iteration due to manufacturing simplicity, it being that it's the easiest to make from scrap materials or recycled materials. After that, choosing the final design, we decided to move on to the manufacturing process, making the main structure of the boat from wood and the buoys from PVC. After that, we decided to do some modifications to make the boat eco-friendly and add solar panels. We also used a formula for buoyant force testing. We used the buoyancy formula to find the buoyant force of the system, it being a total of 8.6 pounds force, and the boat only weighs approximately 6.2 pounds, meaning that it will float to the central line of the buoys with no problem.
Motors. The motors chosen were the T100 thrusters. These motors are purpose-built for use in the ocean and was designed specifically for use on ROVs, AUVs, and robotic surface vehicles. They are made of high-strength UV-resistant polycarbonate injection molded plastic. The core of the motor is sealed and protected with an epoxy coating, and it uses high-performance plastic bearings in place of steel bearings. A specifically designed propeller and nozzle provide efficient, powerful thrust, while active water cooling helps cool the motor. And they are usable with Arduino, ArduPilot, Raspberry Pi, BeagleBone, and many other embedded platforms. In our case, it will be used with an Arduino.
The circuit is powered by two 12-volt LiPo batteries. They are connected in parallel with the two motor electronic speed controllers. Two step-down converters are also connected in parallel with the batteries. These convert the 12-volt input into a steady 9-volt and 5-volt outputs to power up the Arduino and Raspberry Pi respectively. The circuit also has a solar panel connected to the batteries, which will charge them while the boat is in the water. The electronic structure of the WaVe robot powers two underwater thrusters that allow the robot to move. The speed of these thrusters are simultaneously controlled by an Arduino board and two electronic speed controllers, one for each motor. The Arduino controls the motor speed based on input received from an ultrasonic sensor. This is meant to avoid obstacles while the robot is running.
Now into software development. Since the objective of WaVe is to get through an obstacle course without hitting any of the obstacles, we need a camera to detect where these obstacles are. Also, we need a brain that can receive the information from the camera and process it to know if there's an obstacle ahead. For this, we obtained a Raspberry Pi and used MATLAB to process the image. As you can see in the images, the camera can now detect if there's a circle in the environment displayed and can now detect the center for location purposes. Color test. The first part of image processing is to separate the backgrounds from any green objects detected. This is why we place various filters to obtain only green objects in the frame. We first use a blur filter to blur out the excessive noise and reduce the background. After this, we separate the RGB layers of the image and process the green layer through a black and white filter and obtain in black the greens that are inside the range we consider is green enough. After, we invert the blacks and whites so that the background is black and the green objects are white. Image recognition. So, the algorithm for the image processing in the camera of the Raspberry Pi should run like this. First, the camera filters out any of the objects that are not green and classifies it as background. The green objects will turn white. Then it takes all of the green objects detected and detects if there are any circles. If both of these statements are true, then it will send out a signal to the motors so it moves in the opposite direction of where the ball is.
Thank you for your attention. There's still some work in progress that we hope to finish during the semester or next semester, and we hope you enjoy.